Hello, welcome to today's lesson. In our last section on statistics and probability, today we're going to be talking about finding inverse problems involving the standard normal curve. We're going to be using inverses. Let's just use inverses. Let's go there. Let's talk about the last problems we have to do with these standard normal curves, which are inverse problems, which mean if you are given the standard normal curve, can you get back to the original data? And the key for doing that is to find your z-value by working backwards. We're not going to work from z-value to percentage of values less than our z-value. We're going to work from percentage of values less than our z-value towards the z-value and then back to our original data. I think this is best done through example. Here are some easy inverse problems to start us out. Find the value of a in each of these statements that refer to the standard normal variable z. The probability that z is less than a is 0.5478. Well, that means that our I value, or I of a, is 0.5478. That's this red area here. What is our a? Well, look in the chart. 0.5478, go up, it's going to be 0.12, just about 0.12, which would make sense because it should be close to 0, because 0, remember, has 50% of our data below that. Here is a problem involving inverses that can be a little tricky. Find the probability that the z-value is greater than a is given that the probability that z-value is greater than a is 0.6. That tells us here that this value here is 0.6. Right here, we have about 60% of the data to the right, or greater than some z-value, or a, we'll call it a there. Well, we have to turn this problem around because our charts give us values less than the a value. So if our a value is there, I still have 0.6 there. Well, if I do that, I can look at my chart until I have 60% of the data, or 60% of the random variables less than a, and that turns out it's about 0.26, which makes sense. It should be a little bit greater than 0, but not too far ahead of 0, given that 0 has 50% here and 50% greater. Well, if my a value is 0.26 for this picture, you'd have to make the jump that a here will be negative 0.26, or thereabouts, by symmetry. And of course, yes, we would expect a to be to the left of 0 here because we want 60% of the data to the right of a. Here's a third example with inverses. Find the probability that z is less, we're always finding a, find the probability that z is less than a is equal to 0.05, or about 5%. Well, of course, if this is 50% here, 0.05 is going to be way down here. But the problem is that will give us a negative a value. We don't have negative a values in our chart. So let's use symmetry. Over here, we're going to have 0.05 as well. Well, that would leave us with 95% of our data. If I call this a prime, we have 95% of our data, or 0.95, from here over. So that's what I want to look up on my chart is 0.95. Where is 95% of my data? Well, it turns out that's at about 1.65. Let's call it about 1.65 has 95% of the data less than 1.65. Well, if a dash or a prime is 1.65, what would a be? Of course, negative 1.65. Again, by symmetry. And what's the problem here? If this a value is going to be negative, we don't have that on our charts. We have to think about symmetry in order to get this one. Here's a good example of finding quantiles. If x is normally distributed with a mean of 100, and remember this is variance of 25, which of course means that our SD is 5. Find the value of k such that the probability that x is less than k is equal to 90%, or 0.90. Well, what have they just given us? They've given us this. They've given us that the proportion of data less than some z-value is 0.90. I told you earlier that the key is to find the z-value. Well, if you look in your charts, you find the z-value associated with 0.90 is 1.2815. 1.2815. That's our z-value. And now we can use our formula. We know that x minus our average divided by our standard deviation is equal to our z-value. Well, instead of x, they're saying find the value of k such that x is less than or equal to k. Well, what will that be? This will be k, some value of k that I don't know, minus our average, which is 100, divided by our standard deviation, which is 5, is equal to some z-value, which is 1.2815. I can multiply both sides by 5 and then add 100, and I'll get k ultimately is equal to 106.405. 106.405. If I'm asked to write in three sig figs, I'd say that's about 106. I promise this will be the last problem we do. The Board of Examiners have decided that 85% of all candidates sitting for the math exam will obtain a passing grade on the test. The actual exam marks are found to be normally distributed, that's important, with a mean of 55 and a variance of 16, which of course means mean of 55, variance 16, which means we want to write our SD as 4, which is the square root of 16. What is the lowest score a student can get on the exam and still be awarded a passing grade? Well, here is a standard normal curve with 0 as the mean. And we want to relate our normally distributed data to the standard normal curve. Well, if we have a mean of 55, we've got to convert that, of course, to a mean of 0. Well, how do we do that? Well, I told you the key to these problems, if you're doing these inverse norm problems, is you have to find the z-value. Here I called it A prime, but it's really the z-value. Well, if 85% are passing, that means 15% are not passing, or 0.15. What is the z-value associated with 0.15? When I do inverse norm on my calculator, which I'm sure I will show you, I get negative 1.036433338. That's the key. You have to find this z-value, because you know it's going to be x minus your average divided by your SD is equal to your z-value. Well, your z-value is negative 1.036433338. What is that equal to? It's equal to some value A, let's call it A, minus your average, 55, divided by your standard deviation, which is 4. Now all we have to do is solve for the A, and when you do that, you get A is equal to, I multiply both sides by 4, and then I add 55 to both sides, and I get 50.85. Something, 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 something. It carries on and on and on. Well, that means, what is the minimum value a student can get? About a 51% is the lowest grade they can get and still pass.